All right. Hi, everyone, and welcome to another episode of AI Wisdom Series. Today, we are with Amit, who is a Principal Solution Architect with AWS in US. And what we have here for today is like a very interesting topic around the MCP. And what I can do, I'll pass it to Amit to do a quick introduction and also provide some context about the topic, and then we can go to the presentation. And I presume we have some demos as well. Amit, over to you.
Thank you, Sam. Hello, everyone. Welcome. My name is Amit Arora. I'm a Principal Solutions Architect at AWS, and today we'll be talking about MCP. I'm sure you've heard about the Model Context Protocol. It's all everybody is building with agents and MCP. So we'll talk a little bit about MCP and then talk about this particular open source solution that we want to focus on today. It's called the MCP Gateway and Registry. So the way things go, we'll have like a short slide deck, and then we will have a demo also of how this solution looks like. And, Sam and I will just talk through some questions, and hopefully this will be interesting.
Yeah, perfect. Awesome. Let's do it.
Let's do it. Okay, so I am going to share my screen. Let's see. What now?
Yeah, perfect. Yeah, visible.
Okay, perfect. So we'll be talking about MCP Gateway and Registry and how to use MCP securely at scale. We'll have some introductions on that topic, set the context of the problem, solution, and a reference demo and next steps. So before we get into the gateway and registry piece, let's take a few minutes to talk about MCP, why the Model Context Protocol is important, where things are heading, and then we will dive a little deeper into this solution that we are going to talk about, the MCP Gateway and Registry solution. So MCP, as you see in this diagram, is a mechanism, is a protocol for connecting AI agents to resources that it needs. Now, these resources could be enterprise data resources, sitting in enterprise databases, sitting in Confluence, sitting in other data stores, SharePoint, what have you. Or these also resources could be enterprise APIs, like an AI agent wants to talk to an internal API, or it wants to talk to external API, like a weather API, and so on and so forth. Now, these integrations prior to the Model Context Protocol coming into picture were bespoke custom integrations, like an AI agent developer would have to write code to say, here is how you talk to my Postgres database, or here is how you call the weather.com API to get the weather at this location. What MCP has done is that regardless of what resource or what data system that you need to talk to, the AI agent needs to talk to, it says, here is a standardized protocol. And so now on top of that protocol, you can build any connection, and the connections, the way to talk to these data stores is now, or these enterprise APIs is now a part of the MCP server rather than the AI agent. So we'll jump more into that, but for the purpose of this slide, the idea is the MCP is a standard protocol that allows AI agents to connect to systems and data sources. Think of it analogous to something like, hey, the World Wide Web, the internet, is based on HTTP and HTML, like a standard framework on which we build all these things. Similarly, MCP would be the standardized protocol on which using which AI agents talk to resources, tools, and other systems. That's the idea over here. Agent needs access to data system. MCP helps provide that access. Now, this particular diagram comes straight from the Anthropic website about the Model Context Protocol, and it sort of puts it into a slightly different perspective. What it says is, hey, everybody is interested in the data that sits in enterprise system, be it databases, development tools, and productivity tools. And this sort of multimodal connection needs to be facilitated by some standardized protocol, and that is the MCP protocol. So whether you want to interact with your file system through a desktop-based AI assistant like Claude Desktop, it needs to talk to these data systems. Whether you want to talk to, let's say, GitHub through your VS Code, which is your coding editor, or Claude Code or Windsurf or anything else, these IDEs also need access to these data systems, like the GitHub being one example, or creating Jira tickets being another example. Or it could be AI agents that you build yourself that needs to talk to these systems. So what MCP then provides is, because it is a standardized protocol, so no matter what exists on the left-hand side over here, in terms of the desktop coding assistant, in terms of the IDEs, in terms of the applications, or on the right-hand side, in terms of the data systems that it needs to connect to, MCP provides a standardized protocol so that everybody doesn't have to build their own bespoke version of how this connection would work. Right, so it's in some sense, it is similar to the idea of building data connectors, but now these connectors are based on a standardized specification. This diagram sort of provides another view of the same idea, that you could build multiple agents. And these agents, through the MCP servers, connect to different data systems, enterprise data systems, or maybe public data systems of interest. And what this also then shows, just goes one level deeper to say that MCP is a client-server protocol. So your AI agent would have a MCP client, and it would talk to an MCP server, like these MCP servers, which are then on your behalf, then or sort of like a proxy, talking to these systems of interest. So the idea here is that my AI assistant, like my AI agent, like these AI agents over here, if you can see my mouse, these agents do not need to understand, hey, how do I talk to the CRM system? Or how do I talk to this ERP system? Like, I, as an agent developer, no longer needs to write code to say, well, what was the API of the Confluence thing? Or what was the API of a GitHub thing? Or what was the API to talk to Postgres? Because that is now abstracted out in an MCP server over here that says, hey, here is how you talk to the CRM system or the cloud application, and so on and so forth. The AI agent consists of a client, and this client talks to the MCP server in a standardized protocol, which is the MCP specification. Now, this client is just something that the AI agent framework would provide to you. So if you're building AI agents in AWS Strands, for example, it comes with an MCP client. If you're building an AI agent in LangGraph, for example, Crew AI, pick any of your favorite one. They all come with an MCP client because it's a standard protocol, open source. So you would just import an MCP client from your AI agent building framework and say, hey, MCP client, connect to the GitHub MCP server or the Atlassian MCP server, which could be hosted wherever. So what that does is it frees up your AI agent from knowing how exactly to talk to these data sources, because that is now abstracted away in the MCP server. Your MCP client, just says, hey, I'll just forward this request as a proxy to the MCP server that needs to talk to these systems, and that is it. That is sort of the power of using MCP or a standardized protocol to make these connections. So all that is good, but and this is some of the things that people say, and they're not wrong when we talk about MCP, that hey, this is all right, great, but isn't this a HTTP with JSON RPC payload? Yes, that is absolutely true. It is HTTP with JSON RPC payload, but the power or the beauty is in the standardization. So MCP was sort of the first framework which says, here is a standardized protocol, and they just actually came up with a very simple protocol, built it in open source so that everybody could talk about it and provide comments. And it's being built up right as we speak, enhanced as we speak in public on the Anthropic Model Context Protocol Specification repository. So the beauty of that is in the standardization. And yes, it is a simple, HTTP with a JSON RPC payload. So then the other thing is, yeah, but this is really nice, but we've always had APIs. So why do I need this? And the answer to that question is something that I was elucidating in my previous slide to say, if you use APIs to talk to these systems, like, to take an example, the GitHub API predates MCP. MCP was only around since November 2024, so just a little, about a year, 12 months. So the APIs existed, yes, but if you wanted to talk to the Confluence system or the Jira system or the GitHub system or Slack through their APIs, then you would need to add code in your agent. Here is how you call that API. With MCP, all your agent does is oh, I need to create a Jira ticket. Yeah, I need to just call the create Jira ticket tool, which is provided by the Atlassian MCP server. I don't actually have to know how the create Jira ticket tool, like my agent doesn't actually have to write code to say this is how you pass parameters, because now the LLM powering that agent will ask my MCP client, well, what is the specification of this tool? How to create tickets. Oh yeah, this is the specification. I'll read it and I will invoke that through the MCP protocol and pass it the parameters that it needs. So I don't actually write code to say, here is how you call the API. That's all abstracted away. And that is the power that it provides, that it is more than just an API. And then we come to the question, which sort of is a leading question to this main solution that we want to talk about, that is this even enterprise ready? So MCP was introduced by Anthropic in 2024. And at that time, it had very limited support, if any, for authentication and authorization, right? And then there's realized, oh, everybody's starting to use it. So we want to build some enterprise features into this. So now, authorization and authentication are baked into it, and there's a whole lot of other things that have been added to MCP since then. So the real problem that MCP actually solves, that it transforms this M cross N problem of connecting M agents to N things, where you end up building M cross N connectors, to an M plus N problems, right? You have three agents and three MCP server. That's it, 3+3 rather than 3x3 connections that you see here. So that greatly simplifies these enterprise architectures. And then it gets better. AI agent can discover new capabilities without code changes. MCP server provide these tool specifications that these LLMs can then read and have a semantic understanding. Oh, this is where I use this tool. This is how I use this tool. So that semantic understanding, provides an ability to the LLM to actually invoke the right tool. And then composability. So an AI agent can talk to multiple MCP servers and say, hey, instead of having a sort of a very rigid workflow which says, call this API, then do that, which, don't get me wrong, might be very useful in certain situations. But composability that MCP provides, because the tool specification is all written in natural language and an agent can talk to multiple MCP servers, it can say, oh, for doing this, accomplishing this complex task, I'll call tool 1 from MCP server 2, and after that, I will pass on that output to tool 3 from MCP server 4, and so on and so forth. So the capabilities of multiple MCP servers can be weaved in together. And so MCP is, more than just being a proxy for API, and it provides other methods, etc., such as sampling, routes, and elicitations. So much more than that. Here's a quick, chart that I like to show. This is the open source MCP servers repository under the Anthropic Model Context Protocol GitHub organization. And you can see that, while this was launched, so up until around like February, March of this year, it had modest growth, plateaued out a little bit. And after that, people suddenly discovered the standard, and there was an absolutely exponential growth after that, just sort of now tapering down a bit. But this is the open source repository, which with the, I think as of a couple of weeks ago when I made this chart, it was like 73,000 GitHub stars. So it sort of speaks to the power of both open source and the adoption of MCP across the enterprise ecosystem. So, whether it is the developer tooling ecosystem, whether it is the different organizations, OpenAI or AWS, Google, all talking about MCP. So the industry validation, contributions to open source, all come into picture here, which are fueling the MCP adoption. To sort of emerge as the universal protocol for AI agentic tool integration, we kind of talked about that. And we'll now talk about all this is really good. So that's super cool. What are the challenges for adopting MCP at scale within an enterprise, right? So, MCP adoption has been great, but when we think about enterprise adoption of MCP, then all the, meat and potatoes issues, bread and butter issues of like, hey, how do I do governance on this? How do I do, tool discovery? I have too many MCP servers suddenly. Are these secure? How do I do credentials management? So all the sort of boring issues, which are super important for an enterprise, they come into picture, and we are now trying to solve, and some solutions do exist. And we'll talk about one such solution today for solving all of these problems so that within an enterprise, I could say, hey, I have these, curated set of MCP servers that I want to allow access. I want to enable for knowledge workers, AI agent developers, etc., within my organization. How do I do that? So these are the problems that enterprises today are grappling with to say, how do I provide multi-tenant access? So I want to provide like access to these 10 MCP servers to line of business one, and these other 5 MCP servers, which line of business one should have nothing to do with, but they exist. I only want to have, these other 5 MCP servers for line of business two. How do I do that? How do I authenticate AI agents as well as humans from to use these MCP servers, right? So all those things are now real issues that enterprises are grappling with. And one such solution that provides a opinionated way of solving that problem is the MCP gateway and registry solution. So this is an open source project, and we will look at this momentarily. We'll also have like a live demo, which says, hey, here is a curated set of MCP servers. Now, what you're looking at is what we would call a MCP registry. Here is a curated set of MCP servers that a IT team, a central IT team, platform team has provided to its organization. And so individual users get to see and use these MCP servers as part of their AI coding assistants, as part of their AI desktops, as part of their AI agents that they develop. And the access to these servers goes through a central gateway, which we call the MCP gateway. And that gateway becomes a central control plane for authentication and authorization, rate limiting, and all the other good stuff that an enterprise identity management that an enterprise would want. And the registry becomes something through which AI agents or AI agent developers can discover, hey, what exists for me that I can use. So when I log into this system, I get to see the MCP servers that are accessible only to me. So my platform admin has put me in a, let's say, an access group, which allows me to access these 5 servers or 6 servers that I see on my screen right now. Somebody else, when they log in, they get to see a different list, maybe an overlapping list, but a different list. And so fine-grained access control becomes a part of the equation right now to say, hey, all these things are now accessible to you. And these other things which are not, which may be accessible to somebody else, are accessible to a different team, and so on and so forth. So in an integration with a identity provider to say what is accessible to you and what is accessible to somebody else, and that way they can have like a controlled access. So it solves these problems of tool discovery. It solves problem of configuration sprawl, authentication and authorization, and all the other things. And it also integrates with the Amazon Bedrock Agent Core Gateway. So you can bring an MCP server and register with this gateway solution. You can MCP server could be the Agent Core Gateway MCP server. It could be a streamable HTTP server that exists like as a SaaS offering from some provider. It could be an MCP server, an SSE, or a streamable HTTP server that you may host, on your AWS account, and so on and so forth. So you can register that with this solution. Let's actually see a real version of this. So hopefully you're now seeing. Yes.
Just before going to the demo, I just got some.
Yes, I think
need some clarity before going to the demo. So for the registry, so like let's say I'm a developer within an organization. I got access to those types of MCP services that I can use to build any sort of agentic capabilities, right?
Yes.
Is it like the right assumption? Okay.
That is
and correct. Then so for the for the agent piece as well, is it like how does it go? Like let's say I want to have an agent which has a kind of limited access to specific data within even a specific data sources. Is it such a those types of use cases also can be applicable for these types of solution?
Yes. So here is how that will work. So let me take an example over here. So you see this, screen over here with a whole bunch of MCP server, and they are in sort of two different colors, and I'll come to what they mean and so on and so forth. But to take care of your question, so these MCP servers that I'm currently logged in as admin. If I change my access, I will see a different list of servers, and then each of these MCP servers provide me a bunch of tools. So let me just click on something. Right. So this particular MCP server provides me, access to these tools, and I have these tools, right?
Yeah.
And these are the tool specification. Now I could have my AI agent talk to this MCP server through the gateway and say, hey, when it does a list tools, it would only get access to the tools that it has access to through the IDP. So what happens over here is that an identity provider, and this solution comes with a built-in solution with Keycloak as an identity provider. So what you can do is you can log into Keycloak, and Keycloak is an OAuth-based IDP similar to Amazon Cognito or Okta or anything else, basically an OAuth compatible thing. You can create groups inside Keycloak, or I should just say IDP, your IDP of choice. You can create groups inside your IDP of choice, put users, and so human users and AI agents. You could create a machine-to-machine account and say, these agents are part of this group, and then this group provides you access to these 3 servers. And within these 3 servers, it only provides access to, this tool and that tool and that tool. Now, through those limited access to those tools, one of those tools could happen to be, hey, provide you access to this data. Now, you may not have access to a tool which would end up providing you to access to like a restricted database, for example, because through that groups to scope mapping, I have said you don't have access to this tool, and that's how it works.
Yeah, so it's more like a kind of the concept of service account for classic application, right?
It is, right? So the term that, so in this context, the term that we would use is that in an IDP, you would have a human account, and you have you can call it service account or M2M account, machine-to-machine accounts, right? So your AI agent is a application, and it would have a machine-to-machine authentication to this solution. So now what would happen is, and to just go one step further, suppose I said, hey, I want to access the current time MCP server in my agent, right? So the current time MCP server provides me access to a tool that, let's say, gets me the current time. So what I would end up doing is I would click on this and say, and this particular thing shows an integration with any of these IDEs. But the idea over here is that I would say, hey, this server, this current time MCP server, is accessible to me through mcpgateway.ddns.net. Like this would be mcpgateway.mycorporation.net, like your own domain name, wherever you have hosted. And you would say current time/MCP, and you would get a bearer token. You would get a JOT token, you would get an authentication token. You could now copy this inside your VS Code, and now your VS Code IDE would now have access to this MCP server. Similarly, if you wanted your AI agent to access this server, you would use this bearer token, which we would provide to you, and put it in the MCP client. So the MCP client would say, hey, I am talking to this streamable HTTP endpoint, and I'm using this authorization bearer token. So when the request hits the MCP gateway, we will say, oh, you want to go to the current time MCP server. We see that. Let me validate your authorization token. So I will then say the authorization server inside the gateway will say, let me talk to the IDP and say, you are saying, well, you're presenting your JOT token over here. Let me validate your token with the IDP and find out what group you belong to, what scopes you have access to, and does that group scope thing allow you access to this server and this tool that you want to try to call. So your MCP client will embed this JOT token and try to access a server of interest, and then use the standard MCP list tools or call tools and so on and so forth. And the authorization server in this solution, and this is where the governance piece comes into picture, the MCP gateway would then, on your behalf, talk to the IDP, the identity provider, and figure out your tools and scope mapping and see if you are allowed the access that you want to access. So if you are allowed the access, it would then let you go to the current time MCP server and call the tool that you want to call, and life is good. If not, if you don't have that access, it will send you a 403 and say, hey, sorry, you don't have access, and so on and so forth, work with your platform admin and so on.
Got it. All right. So like Amit, because the thing is, I'm trying to just use the analogy for API gateway and trying to see
Yes.
like whatever that is applicable to API gateway can be applicable here. So I can see
Yes.
like the governance piece and all those things. Like, like in API gateway, we got this concept of throttling the number of requests.
Yes.
How it's actually play here? Do we have like similar concept?
Yes. So that is, let me go to the GitHub repository. So the short answer is we got a lot of requests for implementing that feature in this thing. And we have this active issue list, which shows our roadmap. And one of the issues in here would be that, hey, we want to add rate limiting, etc. Because we've talked to many folks and say, hey, we, just to your point exactly, we would like to have more governance feature, and the rate limiting and throttling is one of the things. So look out for this, should get implemented in a couple of weeks and so on and so forth, right? So you'll be able to implement some sort of throttling to say this individual user or that agent should not be able to call like, more than 5, pick a number or something per minute, or these tokens per hour, and so on and so forth. So we're implementing that. But yeah, I mean, that provides a good segue to the GitHub repository for this issue, for this solution, and provides a lot of instructions as to how you can get this working, what's the latest updates on this. And we can talk more about that shortly.
So in terms of like the concept for that specific case, I'm just trying to just imagine how like when it comes to the API, you can say, oh, it's the number of requests, and then it comes to the API gateway, and then it knows like, let's say per minute, how many already done. So how it's actually like, because I'm just trying to understand, like when an agent is trying to just make a request, is it how that count is going to look like? Like, I'm just trying to understand how that kind of like rate is going to be. Is it more like a kind of, it still is going to be the API request to that specific source? Is it like that's the things that is going to be used to just throttle the request?
So yes, so we are thinking of 2 or 3 different approaches. Let me actually go here, and this is still being designed. So all of this is a good discussion. Yeah, so I just wanted to bring this up here for a second. So these are some of the built-in metrics that we provide. So the solution also comes with a Grafana dashboard, and we emit metrics through OpenTelemetry, etc. And one of those metrics is like, requests per second, and, which tools, and, how many tools, your tool calls have been made, how many calls to different MCP methods, etc. have been made. So we have like 2 or 3 numbers to play with. If we talk in terms of MCP, we could say we could put throttling on, like, the most usual way to think about it would be to put rate limiting on individual MCP servers, right? This agent, because each agent would have an identity, we would have a client ID coming inside your JOT token. So we would know who this agent is. And we could say request coming from this client ID to that server, no more than n requests per minute or something like that. So we already track those metrics. We just have to implement throttling on that, which is why I brought this up, right? So this throttling could be implemented, or probably would be implemented at multiple levels, would be no more than n requests per minute to a particular server from a particular agent, or no more than m requests to an individual tool within the server, right? Maybe you just end up calling a particular tool many times, right? So we could implement at a tool level, we could implement at a server level. We could also implement like a overall cap at a volume level, that in a day or in an hour, no matter which server you call, you cannot make them more than like 1,000 calls in an hour or some such number, right? So it would be at that level, at the level of tools, at the level of servers, and then would be rate based, would also be volume based. So no more than 1,000 requests per hour, right? But also no more than, like, pick a number, 10 requests per minute or some such thing, right? So we already have these metrics inside the solution today, which is why I brought this. So the solution also comes with this built-in Grafana dashboard. So you can see these metrics, just not enforce rate limiting, which is something that we are working on.
Okay, got it. And then another one, like when it comes to the API, again, we usually, like for the application, we have an API, and then there is another layer of SDK to just make it suitable for the cases that if for like a specific language. I'm not sure whether we got kind of like similar things when it comes to the MCP. Do you think we will have another layer also on the top of MCP soon, or these cases?
Yeah, so that layer in a manner of speaking, exists. So all the agentic frameworks come with their own MCP client. So, you could import like, hey, from I mean, not exactly, I don't remember the syntax, but like from LangGraph, import MCP client, or from Strands, import MCP client. So you have that SDK support already. I mean, certainly for Python and TypeScript. But I've heard about folks, obviously they want to use MCP in Java. So, pick your language. I mean, it's back to the earlier slide that we had that, hey, this is just HTTP with a JSON RPC payload. So, pick your language of choice, but all these frameworks exist, which today provide SDK support.
Okay. And then specifically on the case of MCP, I presume there are like some other kind of like frameworks, like let's say MCP, like A2A. So is there like a kind of like a list that you can just mention, or even like, for instance, do you think if like for a business or a company, they are working for both MCP and some other.
Yeah.
So that gateway, do you think it can be expanded to those cases, or whether they need a specific gateway for them?
So, well, that's an excellent question. And those are all active discussions. So there is things like what you see on your screen, which is like a gateway, MCP gateway and registry. But also, speaking of A2A, A2A also has the concept of an A2A server, and how different agents talk to each other. Do they also need a gateway? And when we talk about this particular solution, one of the most common requests that comes in is, can I just import MCP servers into this, or can I also import my agents into this solution so that I don't need two separate gateways or two separate registries? Can I see like, one of these tiles over here can be an agent rather than an MCP server, right? So those are things we do think about. One pattern, and in fact, back to one of the GitHub issues, is the idea of an agent as a tool, which means that I could have an agent, but I could wrap that agent in an MCP server. Let me see if I can find here, but it is agent as tool integration, right? Okay. So this was one of the requests that we've had to say, hey, I want to import my agent into this so that I can use my agent as if it was a single tool MCP server. So, I don't have to have a separate sort of framework.
Is it more like for the multi-agentic use cases, or
you could exactly, you could use it as part of a multi-agent thing so that you have a single agent and it's able to invoke multiple agents through this gateway, and those multiple agents appear as single tool MCP servers. So they all register in this registry. So an agent can discover, let's say, other agents through this registry because they all show up as single tool MCP servers. So the agent as tool paradigm would sort of harmonize this. That's one way. I mean, I can't say that's a prescriptive only way of doing it. That's one way, but A2A has its own, A2A server and registry agent registries and so on and so forth.
Okay.
So people are exploring that.
Okay, got it. And then in terms of like the guardrail, any like specific, because like we talk about the governance, about like all those kind of throttling. In terms of like the I would say the way that the agent is going to talk to the MCP server and the other way, is there, and putting the guardrail around that sort of communication. How does it work?
Yes. So there are two topics in that. One part is just the authorization and authentication, and the guardrail is a slightly separate topic, and we should talk about both. So the authentication and authorization is today baked into the solution, which is like that JOT token thing that I was showing you, that you will get a JOT token from this. So when an agent wants to talk to, like, for example, this is a streamable HTTP MCP server that they can then access through this gateway. When they want to talk to it, hey, we provide you a JOT token and we'll validate that JOT token. And if you don't have that token, or if you don't have that groups and scopes access mapped out, we'll just send you a 403. So that is that. That part, that is called ingress authentication. That's available today. That's how it works. Yeah. Then there is a concept, so then there is a concept that, for example, like the Atlassian MCP server, right? It may require its own JOT token to talk to certain tools to, hey, you want to create a Jira ticket? Well, to you as a user, I assigned a token to you and present me that token, and only then I will allow you to, this tool to be successful. So we allow that second JOT token, it's called egress authentication, to pass through this system. So you can say, hey, we will validate your ingress token to say, do you even have access to this create Jira ticket tool? Okay. Then once you have access, well, Atlassian would require its own token for you to be able to create that Jira ticket. So we'll allow that second authorization header to pass through. So we support what is called the three-legged auth. So that's just the authorization authentication story that's in place. The second part to what you mentioned, which is very interesting, is the guardrails, the runtime guardrails, which means I, as an agent, call this tool. I want to make sure that there's no malicious thing, there's no SQL injection attack happening, there is no tool poisoning happening. Similarly, the tool provides me a response. I want to make sure that that response is, again, secure and not malicious, etc. So that is an element of runtime security. There are some third-party open source solutions in there, which are available today, and we are thinking, kind of working in discussions with them to have that integration today with this. So hopefully in a few weeks we would have that sort of runtime integration also, where you can say we can scan these tool inputs and output to make sure they work within whatever security paradigm, within whatever policy enforcements that you want to allow. So the guardrail aspect of this, which is more runtime. So that would be integration with some 3P solution that we are thinking about. Look for it. Should be there. There is another aspect if we really touch upon that governance and security piece, which is called MCP supply chain security. So, all these purple things that you see here, what are these? Just to sort of, right? So these are imported, these are public MCP servers. These are publicly hosted streamable HTTP MCP server, which are imported from the Anthropic public registry. So we have our registry, which is this one, but Anthropic also recently, a few weeks ago, or maybe last month or something, published an open source, published a public registry. So, there are a whole bunch of servers. Now, if you wanted to import some server from there, you can do that today with our solution. Now, well, that's all very good. We support the Anthropic registry API, by the way. But so that's all very good. How do I know that the server that I'm importing, did I run a security scan? Did I run some sanity checks, etc. Right? So that is called MCP supply chain security, and we are, as of right now, working on that. Integrating an open source solution which will do that. So the onboarding of an MCP server into the solution would automatically have a step to say, hey, we will run a scan on your server, and the scan will return potential vulnerabilities, and based on that or not, potentially, and based on that, we will decide, well, or you can, as a platform admin, decide, hey, do I want to add this MCP server which has this, this low priority security threat, or, whatever, maybe a critical threat, and no, I don't want to add it, right? So that will be very soon a part of this solution, where before importing anything, automatically a scan runs and provides you a report, and based on that, you can decide whether or not to add it. So lots of, cool security things being added to this.
Okay, got it. So do you have anything else that you want to show, like in your screen? Or,
I think, I'll just point folks to, well, you can, we support Anthropic API, so you can talk to this registry programmatically as if you were talking to the Anthropic public registry. And then this is the
MCP gateway registry.
Yeah. So this is the URL for the public Anthropic for our open source repository. So please take a look at that. We build in public, so you have a whole bunch of issues, and these are the things that we are currently working on. If there is something of interest, you would like to use the solution and like to request for features, here is the place to do that. We have a bunch of pull requests open, as you can sort of see. Lots of cool things happening over here. So do check it out, and don't forget to add a GitHub star when you see this. Here are all the latest and greatest new things in this. Takes less than 10 minutes to get started, we provide pre-built images for the whole solution. The solution is we didn't go into the design, but all the design is documented here. The solution is a bunch of Docker containers, which you can deploy on Amazon EC2, on your EKS cluster, or if you really wanted to get started in less than 10 minutes, you can deploy this on your Mac laptop. Less than 10 minutes, works with pre-built containers that we've published. So up and running. So do try it out. We also integrate with, you see screenshots here of VS Code. So, we also integrate with VS Code. So you can add all these servers through this registry into your VS Code and integrate with it. So all that is supported as well.
And it's just a JSON file, right? For adding any of those.
It is just a JSON file, right? So basically something like this, right? So if I wanted to add this server, I would just, cursor, client, Claude Code, just copy paste from here, put it in your VS Code thing, up and running. That's it.
Yeah.
That's all there is to it.
Yeah.
There's a whole bunch of other features into this, which I would encourage you to explore. And this is sort of fully enterprise ready with all the observability and built-in Prometheus Grafana dashboard, Anthropic API integration, usage guide, lots of documentation available for you to look at. So yeah, do look at this and check it out. Start our GitHub repository for good karma, and any requests you have, we're happy to engage with you.
Awesome. Thanks, Amit. So if you stop sharing, I have two more questions that I wanted to ask face to face.
Okay.
So one is actually more, like when we started to talk about all these LLM, I remember like two years ago, I was actually just writing a white paper. And then in that time, we were thinking about like the gateway for LLMs, and then things like Bedrock and like other provider also providing the same thing. Then we come to the agentic one, then we have like this MCP, I would say gateway, and then for sure like the agent gateway, or like more like a type of marketplace for the customers. So in your view, how all these different, I would say, things can just work together, like in general, and how what would be the like if you want to enable that level of governance that you want for the models, for the agent, for the MCPs that there, and even like some other component that we may miss. So how do you think?
So that I have to say is a multi-million-dollar question. I mean, it's not an easy solution at all. We can think about this in 2-3 ways, right? So LLMs, we should now consider as a piece of infrastructure, like, think of them as EC2 instances, right? Then you have agents, then you have agents, MCP, I would say LLMs, MCP server, agents, and so on and so forth, right? So now, but these are access patterns to these things are sort of different, right? I mean, agents would access LLM. So, most organizations that I work with would access LLM through an LLM gateway. That's a de facto now standard. Now, some LLM gateways have also sort of transformed themselves to be an LLM gateway, but also a MCP gateway. So for example, if you look at Light LLM, something very common, they also offer themselves as a, LLM gateway, which is also an MCP gateway, right? And so you could go the open source routes. You could use other solutions, like Kong is one solution. The solo.io has like a sort of unified type of gateway. Our solution is one, but we sort of think of ourselves primarily as an MCP gateway, not an LLM gateway, certainly not an agent gateway, although agent as tool is a pattern that we're thinking of supporting. So you need to see what works for you. And many organizations that I see working with, they would implement this multiple things at different layers of the stack, because like an LLM governance is slightly different than an agent governance, slightly different than an MCP governance. So, should there be like a single gateway which acts like for everything, or should there be multiple gateways, but then depending upon how your applications or your users want to interact with it, you provide them an easy to use layer, whether that's an SDK layer, whether that's a marketplace registry type of solution. That depending upon your organization's need, you need to think through this. Like, I mean, it's not an easy solution, but there are certainly solutions out there which tend to do all the things.
Yeah, because what I can see is just mainly kind of like enterprise types of use cases, right?
Yes.
Like when it comes to this gateway. Otherwise, like when it comes to like startups, SMBs, I wouldn't see like a lot of, uh, I wouldn't expect a lot of focus. But then when it comes to the enterprises,
Yes,
those are like the
exactly.
key ones. They have like different departments. They wanted to just have that
That's
level
exactly
of
right, right? Yes.
and
So
that's
if
the
you
case.
have things like multi-tenant things and you access models through many cloud providers and you also build your own MCP servers, but also you use SaaS MCP servers, like then, then you need all these things. If, otherwise you can just use, something like Bedrock and that is your gateway.
Yeah.
And that's great.
True. So, and then one more question. So the thing is, so I'm sure you work a lot with this specific, I would say, frameworks. Based on your experience, do you think that's going to be like the future-proof framework that we need for that enable that communication across or do you think there are like some areas that we still need to find a way to use MCP and also address those gaps or cases? And maybe in 1 or 2 years, we come up with like a new frameworks that can be, I would say, surpass the MCP and can be, or even like some others like A2A, or do you think MCP would be the one, or?
I would be the last person to hazard a guess on like, hey, this one framework would be like the future framework, so put all your bets on that. I would say, and there is a reason why all these frameworks, whether it is MCP, whether it is A2A, they're sort of open and publicly being developed and discussed, and you can see where they are going because these things are evolving and these things are being built as we speak. So one thing, maybe to answer your question slightly differently, one thing that LLMs and the advent of these foundation models in software development has done is that the cost of building and experimenting and finding out, putting it out and finding out what works is gone down drastically. So now we are at a point where I would say prototype first, find out what works and iterate super fast on it, right? So I think we will find out what happens because the cost of building these things and iterating and developing is now very trivial.
Yeah.
So I see MCP staying. I definitely see A2A not going away at all. I mean, it has a slightly different use case than MCP in terms of, agents being able to talk to each other versus MCP saying, well, I want to enable agents to talk to systems and data sources and so on and so forth, right? So there is definitely some overlap when we talk about agents as tool, but I think both these protocols have their own space and they are both evolving very well, both evolving publicly, and I think both will stay. I don't quite put that as like, hey, is this our DVD versus Blu-ray moment? Like which standard will win? I don't think that is the case here.
Because like I'm still using my API analogy, so that when it comes to the API, we got those crude methods and then payload and then the code, and API become the standard for all those I would say classic application communication.
That's exactly right. So we will find out where this goes, but this is all being built publicly and lots of infrastructure being built to support these things. Lots of effort going on in making these things enterprise ready. So I expect both of these things to be around for a bit, but we will see. Who knows?
Okay, awesome. So thanks. So like the repo was the main one. Like if anyone wants to contribute and if anyone they want to do experiment with the MCP gateway, is there like any other resources that you can think of, or is it the best place?
Repo, yes, and I'm sure we'll put that link in the YouTube video description. But yes, that repo is a self-contained thing. The repo would also show you on the towards the top right a link to documentation, which is all sort of dynamically generated automatically. So it will give you access to a GitHub.io web page, which has all the documentation to go with it. So, but basically, yes, that repo is the place to go to see how things work. All the design is there, all the requests that you would like to, hey, I need this feature, etc. And we're building super fast. We have like at least a release a week and so on and so forth. So lots of cool features being added. So look out for that.
Yeah, and to be honest, we expect like we are in the world of AI-driven development, so we should be super
absolutely. Yes, absolutely.
Awesome.
Okay.
Thanks, Amit. Yeah, it was a very good, I would say, discussion, and really enjoyed it. And
this was fun.
So what I do, as I said, like I include those resources, and wish you all the best. And I definitely need to check their repo and also see, and even like maybe request some more features.
Yeah, absolutely. And if you
for the
have like
gateway.
customers who would want to see this and have a POC, have a demo, let me know. Yeah, and I mean like that, the starter kit with the quick start guide on setting this up on a Mac takes less than 10 minutes.
Yeah.
Try it out. That's how most of our customers are now experimenting with it.
Awesome. Thanks, Amit.
No.
Thanks for your time.
Yeah, let me know when the link gets posted.
Yeah,
Bye.
for sure.
Bye.
Thank
Bye.
you so much. Bye.